Hi everyone, how's it going? My name is Andrew. I run Wasatch Electronics. We are a repair business that specializes in graphics cards. And by we, I mean it's just me. I'm the owner and the technician. I've been fixing graphics cards for about the past 2 years, and I've been doing electronics repair for about the past 7. So I definitely don't know everything when it comes to graphics card repair, but I've fixed probably 150, 200 cards, somewhere in that range at this point, if not more, and I'm constantly repairing more. So I do feel like I know quite a bit, and I'm also a part of a few communities that have amassed quite a bit of knowledge about graphics card repair. So I've got a lot of knowledge as far as actual repair goes, micro soldering, graphics cards, all that stuff, and a lot of knowledge as far as graphics cards go in general, and knowledge that's come from others. So I wanted to go over some of the current controversy with Gigabyte and why these Gigabyte cards are cracking. In this video, I'm going to cover a handful of different subjects. I'm hoping to fill in some gaps that have been left by the videos and articles that are already out there on this same subject. So we're going to cover the Gigabytes cracking at the locking tab. We're going to cover other cards cracking, screw holes cracking and screw hole placement, PCIe lane cracks. I'll show you guys the Gigabyte 3080 and 3080 Ti trace view. I will talk about what is involved in actually repairing these cards, and then we'll talk about a couple other related issues as well. So let's start by looking at a few of the current videos and articles that are out there. Jay's 2 Cents has a video called These GPUs Are Cracking and the company refuses to warranty them. Lewis Rossman has a video, Northridge Fix has a video, and then we have articles from Tom's Hardware. This one's called Gigabyte RTX 30, RTX 40 series GPU PCBs are reportedly cracking. There's an article from Guru 3D, and there are other countless articles as well as other countless videos from creators on YouTube or other video platforms. I want to kind of correct some information that's in those. There's a lot of missing stuff, and there's a lot of incorrect information in these articles and videos. So I want to kind of fill in, correct, and add a bunch of information to what's already out there, coming from a more tech and repair aspect as opposed to just an entertainment aspect. Let's take a look at some cracked Gigabyte cards. This is a 3090 Eagle PCB, and this is the area where they usually crack by the locking tab. It goes up here where I believe this AND gate would be. We get a couple resistors, a couple capacitors, and then the screw hole right here. So the crack usually comes right off of this area, and it can even extend up here all the way to the screw hole and even past that on the other side. But I'll show some of that and explain that a little bit later. This is a Gigabyte 30 series. You can see the crack right here, and you can kind of make out, if you look really close, that it's going down a handful of layers about halfway through the PCB, and it's coming, I can't tell if it's cracking all the way up through here or if that's just the PCB, but it's cracked at least up to here. This is another one. I believe this is the back side. I think this was a 3070 Ti, something along those lines, but you can see it's not very far, but that's all it takes, and that is enough damage to stop the card from working. This is the one that's in my thumbnail. This is another 30 series card. You can visibly see the cracked traces this time. There are 3 of them right here. And then I guarantee this is cracked lower through other layers as well. And I guarantee other layers are cracked and other traces are broken. This is one that's been drilled out for the most part. So all of the cracked area has been removed. As you can see, this one made it up to the screw hole up here. So that had to be drilled out. This had to be drilled out. If you look really close, you can see some of the traces right here that are going to need to be reattached. And there are many more over here that aren't currently visible. Actually, maybe they are. There's some, you can see them right here in that layer. They're kind of hard to make out unless you know what you're looking for, though. This is another one, and you can see a lot better on this one the actual layers and the traces. So that here there are a couple traces on this lower layer, and then there are a lot more on one of those upper layers of the PCB. Wrong direction. This is a 3080 or 3090, I'm not sure which one, that's also got a crack again on the back side. You can see it's going maybe a third of the way through the PCB roughly, and it's small, but again, that's all it takes. This is another one that kind of shows how small the crack is. Another 3090 that's cracked, another Gigabyte, and the infamous Gigabyte arrow. And this one's the same. This one's a little hard to tell. I think the crack extends to about here, but it might be going even further, but that's a pretty serious crack. Here are a couple photos from a 3090. You can see this one's already been drilled out as well, and if you look really close, you can make out all of the traces that are going to need to be reconnected in here. This is a nice microscope view. Here's another photo of that same card. Looks like this has already been covered up a little bit with some UV resin. This is probably mid-repair. There are a couple other traces right here that need to be repaired. And here we go. Here it is a little more open. So a couple traces in the lower layers, and then a few that needed to be repaired in the upper layers. And might actually still be able to see a little bit of that crack right there. So this one was probably, yeah, mid-repair, needed to be drilled out a little bit more. This is a card of my own. This one was pretty bad. This is one of the worst Gigabyte cracks I've ever seen. You can see the crack going up right through this area. It's a little hard to make out, but it runs right through here. And then additionally, you can see that the crack goes right here along the screw hole and along the screw hole on this side as well. Here's another photo of the same card. Again, you can see that the crack comes up this area right here. This was a really bad one. And right along the screw hole on that side and along the screw hole on this side as well. And here is a photo of this all drilled out. This is not cleaned up. It's just a rough drill. But this is what it takes to get rid of that crack. When the crack is this bad, this is how much drilling I had to do until I saw no more cracking. So I had to completely get rid of all of this area. I'm, maybe 1, 2, 3, 4, 5, 6 or 7 layers deep over here. And probably about the same on this side as well. And at this point, I'm getting close to the memory module over here, not to mention the core and this memory module that's already up here. These caps and everything that was in this area has already been removed. As you can see, these guys are here. Took those off. But this is what it takes just to get started on these cards. You have to get rid of all of this, and that's not even starting the actual repair itself. So that right there is already a lot of damage that is done to the card and that needs to be done to the card just to have a chance of getting it working again. This is a Gigabyte 3070 Aorus that I worked on recently. I replaced a couple memory modules on it. This one did actually have some other physical damage, so this one probably was dropped or shipped incorrectly in a pre-built, something like that. But you can see the crack on this one right here. It's through almost all of the layers, but luckily it doesn't go in towards the center of the board really at all. So I used my multimeter and continuity mode to confirm that none of the traces were broken. Everything was still intact. So I fixed this card. I added a little custom support bracket here, which is not the best, but it's better than nothing. And then I let the customer know to mount this card vertically or it likely will crack. And if it does crack, it will stop working and it probably won't be worth repairing. The card still needs to be supported if it's going to be vertically mounted, but that's a good way around these cracking issues is vertically mount your card, make sure it's still attached to something, and then you don't have all that stress on the PCIe slot. This is a card I just wanted to include for fun. This is one I bought maybe a year or so ago, and if you can tell, it's pretty bowed over here. This slot is kind of bent up. Obviously, the fan is coming off. I had some other photos, but if you looked at it from this side, the whole card was bowed like this. Here's the PCIe tab. And as you can see, there is a very large crack across the whole thing. I ended up using this card just as a donor. I took the memory off and I took the core off. And I think I actually sold it to a friend. I didn't have any PCBs to put it on at the moment, and a friend of mine needed one. So You can see how bad that damage is. Yeah, again, this one was just kind of for fun. This was a horrible card. I actually kind of attempted a repair on it. I drilled all this area out, but there were just so many traces that run through here internally and on top of the PCB. You can just see on top of the PCB alone, all of these data lines would need to be repaired, along with any other internal traces that run in this area, which is quite a lot. So yeah, this one got the title of parts card. This is another card of mine. I worked on this maybe about 6 months ago. I believe this is a Gigabyte 2080 Ti, if I'm not mistaken, something along those lines. But it had a cracked PCIe locking tab right here in this corner. You can see this is the little support bracket that I was talking about before. It works okay. It's better than nothing. But you can see the jumper wire that I ran from the PEX reset pin all the way over here to the AND gate that signal is supposed to go to. It typically runs right along the bottom here. You can kind of even see the trace. I think this might have been the trace, or maybe it was actually an internal trace, because I probably would have just repaired that if that was the case. And it had cracked it, so I had to drill that out, add some epoxy there. I stuck this on for a little bit of support, and then I ran that jumper wire. If you are missing the PEX reset signal, this AND gate will not output, and the card will not fully initialize, so it will basically never fully power on. It's not going to show up in your system. At least I don't believe so. If it does show up in your system, it's not going to work. So this is 100% necessary. And this is a 2080 Ti, so I don't know if this one was physical damage or what. It probably was physical damage, but this is just another example of a cracking Gigabyte card. This is the last one that I'll show that's Gigabyte. This was another, I think a 20 series, something along those lines. But this one had the locking tab completely broken off. This one's also kind of just for fun. I just wanted to show this. So you can see these traces in here, the vias in here. I think this one had 2 broken traces. Luckily I had a schematic for this card, but after a while I figured out that this gate was missing a signal, so there was a 3.3 volt signal nearby, and it happened to be the same one that's supposed to be routed through here coming out of this via, so I luckily just ran a little jumper right there. That was nice. I didn't have to run a jumper all the way across the card. And then I also had to run one jumper because I think this via broke, so I ran that from there to the actual via, or actually no, there was a via right here, but it was separated because it cracked right along there. You can see this via going straight down. That one was kind of the same deal, but this one was actually broken. So I ran this wire, ran that via down. Topped it off with some UV resin, and the card worked like a dream. So that one was just kind of a fun one I wanted to toss in. So let's talk about whether this is a Gigabyte issue, an end user issue, or a shipping issue. I think it's kind of a mix of all three, to be honest. I think first off, I've seen a lot of these cracked cards coming from pre-built PCs where the company didn't support the card well enough during shipping, and it got jostled around or bumped or knocked, and that's what caused the damage on the card. I've seen that on a lot of Gigabyte cards, but also some other cards as well, so that's definitely something that contributes to this. I have also seen end users causing this, though, moving around their PCs and not being careful with their cards, especially on the Gigabyte cards. You can see how far out the PCIe locking tab is, and just the PCIe slot in general. If we compare it to something like an Asus PCB, obviously the PCIe slot has to come out so far. Like this is consistent over here from here to here on the Gigabyte and the Asus. I would assume so, at least, or it's pretty close, if not the same. But on this side, you can see this Asus locking tab is super small, and there are some traces that run down here, so they're kind of guilty of doing the same thing that Gigabyte is doing, unfortunately, which I think is not a good idea, running traces that close to the edge of the PCB, especially in an area like this. But you can see that the area is so small and it's so rounded, I feel like it would be a lot harder to get a crack on an Asus card than the Gigabyte card, with how much area there is right here. If this is in a motherboard or a riser or whatever, mostly a motherboard, there's so much area for this to flex. If you guys saw Jay's 2 cents video, it's an okay video, but you can go look at how much this PCB flexes compared to this PCB. Part of that is because of this mounting hole right here, this screw hole. That does a lot to support the whole PCIe slot. And this one, it's got so much sticking out. Like, this just flexes super easily. And flex is okay. The problem is that this just also has a cracking issue. So if it can't flex, like a bridge, it's obviously just going to snap when there's any sort of force on it, or twisting, torsion, anything like that. It's just going to break, which is not good. So it needs to be able to bend. But the Gigabytes specifically have a lot of cracking issues. This is a NVIDIA FE. This is an FE 3090. And you can see it's got kind of the same thing as the Gigabyte going on here. The Asus has that small tab, the Gigabyte has the larger tab, and the FE is kind of the same deal over here, honestly, which is, it's okay, but it's not the best. It could be better. That locking tab is huge. And this 3090 FE, I got one of these in maybe a couple months ago. The cooler on these things is absolutely massive. So I'm kind of surprised that I haven't seen more of these FE cards with cracks over here. But I think the reasoning for that is just because this screw hole is so close to that locking tab. It's on the Asus, you can see it's also pretty close. But then I think the Asus saves itself by not having a lot of area sticking out here. It could also have to do with maybe the cooler weight, something like that as well. I don't actually know if the Asus cards are any lighter than the Gigabyte cards, but they've got something going on here that is causing these to not crack, or not crack nearly as much as the Gigabyte cards, which is a big thing. And even though they have the screw hole that close. So I think it's the combination of having the big locking tab and PCIe area and that screw hole so close. It's really easy for the card to bend right here, and that gives it an easy spot to jump to with that bend right there. Compared to the FE, which again has that big locking tab, but look at how far away the screw hole is. There's one over here, but like that's not going to crack from here to here or anything. That's a huge distance. It's not going to crack through this area. That screw hole is so far away, it's not even going to touch anything. So this area is probably just going to bend and flex a little, but it's not going to crack like the Gigabyte cards are right here. So I think it is, again, kind of a mix. Some of it is shipping damage. I've seen it on other PCs as well, ones that people have built themselves. They move around the PC, they're not careful with it. They get a super heavy cooler card like one of the bigger Gigabyte 3090s, and they don't support the card properly. Or it's Gigabyte's issue in that they kind of have this screw hole close with the large slot. I don't know if it has to do with the composition of their PCB and maybe what it's made of, or if there is more or less copper in this area, which maybe makes the card weaker. But a big problem as well is that they are running traces through this area. So obviously the PCIe lanes are down here, but there are so many traces that run right through here, which I'll show in just a second, in this area that is just, there are a lot that run literally right through here, which is so close to kind of a pivotal point of the board. And when that cracks, it's done for. Again, Asus is kind of guilty of that same thing. I don't know about Asus layers. Unfortunately, I don't have the layer view of their cards, but you can see a couple traces running right through this same area. I am not a PCB expert. I don't design PCBs or anything. One day I would love to do some of that work, but I have yet to. I just from a repair aspect and taking in a lot of these cards, looking at a lot of these cards, being in this kind of world, it just seems like not a good idea to put these traces in an area where it's going to slot into a motherboard right here and there's going to be weight on this. That just seems like a bad idea to me. So hopefully that's something that will change in the future. You can see on the FE there aren't any visible. There's a plane right here, whatever that is, maybe ground or power or something, but I don't see any traces running through right there, but I guarantee there are probably some. I don't know how close to this corner or edge they come, but there are definitely some that run probably through this area down to the other side of the PCB. So I think they're all kind of guilty of it. Gigabyte kind of just has a poor design in my opinion, but it is also kind of a mix. So I don't think we can put 100% of it on Gigabyte. Some of it is physical damage, but I also think that physical damage comes as a result of the PCB design that they've chosen. And I don't think it's right for them to deny warranties because of this issue. Now, some of these cards, of course, that are damaged and the cracks are super bad, I don't think there is a doubt that that is just a user issue. Regardless of the build of the PCB, I've seen Asus cards cracked. I haven't seen any FE cards cracked. They probably exist out there, but even though they're pretty rare, I've seen Asus cards cracked, and like that's got to be user damage. There's no way. And there are certain Gigabyte cards. Some of the ones that I've shown have to be user damage. I think even one that I pointed out was user damage. There's no way that it is not. But up to a certain point, I think they should be covering these warranties because it's to an extent a design flaw. Like just the way that they designed this, there's nothing in their manual that says, hey, you need to support this card properly. That's the other thing that these manufacturers need to start doing, is including some sort of support. I wouldn't be so mad at them if they included a support and said, hey, if you don't use this support, it's going to void your warranty, because not necessarily because of this design issue, but just because our coolers are so heavy, these cards are getting so large, the backside can only support so much, so you need some sort of front end support. I know that I wish I had an image saved to this. Maybe I'll toss it up on the screen, maybe not. But there are some older cards that used to, back in the old days, I never had any experience with them myself, but I've seen them, they exist. The cards had extra kind of a support bracket on the front, and you would also screw that into the PC, sorry, to help support everything. That would screw into your case, and that would kind of help support the front of the card. And back then, cards were not big at all. So that's really something that we need as these cores start to produce more heat. The cards use more power, so we need bigger coolers. These cards need some sort of support at the front. I know that a lot of people buy third-party supports for their cards, but that's something that could be included by the manufacturer. And then I wouldn't be so mad at them for being like, hey, you need to use this, because if not, there's a potential to damage to your card. If you're not using it, we're not going to cover this under warranty. Excluding a lot of details there, a lot of other things that could happen. You know, that's still kind of a shady area, but I think that would be a good start, is getting supports built in for these cards, or supports coming with these cards, and in hopes that people will actually use them. Now let's go ahead and take a look at the trace view. This is the trace view for the Gigabyte 3080 Eagle, which also covers the 3080 Ti Eagle, and I think one or two other cards. They use the same PCB, they just have different coolers. So what you're seeing right now is the top layer, and this is kind of the area that gets cracked. Let me pop in the bottom layer as well. So you can see this is where the locking tab sits, is kind of right here. It's not going to show because there's nothing there, but this is kind of that area. If I am able to zoom in a little bit here, oops. This is what I showed earlier. This is where that AND gate would sit if it was populated. If we go back to here, you can see, so this is kind of the area that it would crack in, this general area right here, right across here. And already, just with the top and bottom layers, you can see some stuff that might be broken in here. Luckily, because this is not connected, it's not really a big issue, so you don't really have to worry about that. But there is a via right here that comes from, again, probably another slot over here, so this probably connects to something across the board. But that comes up, goes over to here, and then that's going to go to another part of the board. That, if the crack comes down this way, that's going to get cracked. And that's just talking about the top layer. If we move down to layer 2, that's just almost a solid layer. Layer 3 is where we start to see a lot of issues. If I overlay this, you can see all of the cracks, all of the traces, sorry, in this area. If your crack extends just up to here, you're cracking 1, 2, 3, 4, 5 traces up to right here. If it's cracking any further, you've got another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 traces up to here. That's 15 already. 1, 2, 3, 4, 5. So another 20 traces all the way from here to here. So if you're cracking close to that screw hole, that's 20 traces already that need to be repaired. And then there's another 3, 4, 5, 6 or so right here. And this is the issue with it also cracking by the screw hole, like in that card that I showed earlier. So if it cracks by the screw hole, there are 6 7, 8, 9, 10. All these traces right here coming right off of this screw hole that you're going to have to repair. And they are super, super small. So they're not easy to repair by any means. And this is layer 3. So it's pretty likely that if you've got a crack, you're going down to layer 3. And these are going to be cracked. Now, layer 4 is also a solid layer. Layer 5 is one where we get another couple traces. In one of the other photos, you could see these. One of the photos that had the PCB drilled out, you could see these. These were the larger traces. So this is actually where that via connects to. Is one of these larger traces over here. And then you've got these. They run across the board, but these are going to get cracked if you have a deeper crack on layer 5. These are all going to get cracked. So luckily, these are easy to repair. They are larger. I guess it's more of like almost a plane, not a trace, but they are a lot easier to repair than the other ones. But nonetheless, they still have to be repaired. It's just another thing to be fixed. Let's look at layer 6. Layer 6 is pretty solid there. Layer 7 is pretty solid there. This could crack and you might have to fix that. I'm not actually sure if that's a power or signal plane though. I actually don't think it is, so probably don't have to worry about that one. Layer 7 and layer 8. So now we're kind of getting into the territory of if your card is cracked on the back side. You can have cards that are cracked on the front or the back or both. I've seen both. So the back side has got another set of traces. If you're cracked on the back side, here are 1, 2, 3, 4, 5, 6, 7, 8. I don't know, I can't count. 8 traces right here in this area. And then a power plane right here that's probably going to need to be reconnected. Possibly, I'd have to look at what that goes to. And so that's layer 8. That would either be a really deep crack or a fairly shallow crack on the other side. I think there are 12 layers. Yeah, 12 layers total. So that's 1, 2, 3, 4, 5 through. So that would be the equivalent of layer 5 from the front. If we look at layer 9, not much. Layer 10. Here we go. Here's where we start to get into some not good territory again. This would be layer 3 from the back side. So this is the equivalent of this layer 3 from the top side. Again, same thing. Lots of traces. If it cracks from the back, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Another 25, 30 traces right here to repair. So there are a lot. And again, they come up by the screw hole. So if you crack by the screw hole, again, that's just more traces. And it can crack at the front or the back on the screw hole as well. I've seen all different combinations. Let's check layer 11. Okay, layer 11's got not much. And I already showed you the bottom. The bottom doesn't really have much. It's got maybe this guy right here if you get really unlucky. So yeah, all in all, if you have a card that cracks on the back and the front, you've got layer 3 and layer 11. Oops, sorry, layer 10. That's a lot of traces to repair. Maybe what, 40, 50, even 60 possible traces in there, depending on where your crack goes. If it goes up this area, you might have a couple extra. If you go down right through here, depends on how far it goes and how deep your crack is and which side it's on. Either way, you've got a lot of traces to repair. Not only that, but you have to figure out where these go. Let's talk about what it takes to actually repair these cards. There was an article out there that somehow got the idea that it was fairly easy. They ended up changing their minds, luckily, and they edited the article. These repairs are not easy. You need certain levels of know-how. You need schematics and or trace views like the one I showed earlier, and you also need equipment. At the minimum, you need a micro soldering iron, you need your flux solder, you need something to drill with, whether that's a Dremel or a little mini hand drill. You need a microscope, definitely, because these traces are tiny. You need some, I think I typically use 34 gauge wire, somewhere around there. So you need some very tiny copper wire. You need alcohol. You need, it's just, there's so many tools, tweezers. It's not something that your average person can do. There is a repair.wiki entry on this. Shout out to one of my friends. His name is Phyro, aka Jeremy. He wrote this, and it needs a little bit of adjusting. We're gonna go through it and fix some things, but it's kind of got the gist of things. So if you want to check that out, I will have that linked in the description. Let's look at the PCB again. So again, if we get a crack in this area, you saw the amount of traces that need to be repaired. So the first thing you have to do to fix this is to drill out all of that area. Earlier I showed you the photo of the card that was cracked all the way over to here. I had to remove all of that PCB. I think this is maybe the same PCB. So you can see just in this one area, this is a front crack only. I got rid of all the crack. I think there was maybe a tiny bit more right here, but all of these have to be reconnected. I ended up having to drill through a little bit more to get rid of this. So there's in this dark blue color, I should have made these a separate color as well, but earlier you saw on the board view, these traces. Again, these all run kind of through this area. These are the bigger ones that were down on, what was it, layer 8, I think? Maybe not layer 8. What layer was it? Let's see, let me find it really quick. Layer 5, that's what it was. These are the bigger traces that run through here on layer 5. That's this one right here, this one right here, I think, yeah, just that one, and then this guy, and then there's another one right here. So those all have to be repaired. Those are kind of the easy ones. You also need UV resin. That's one thing I did miss. You need some sort of UV curable resin, and you could use enameled wire if you would like, but copper wire, straight copper wire is going to be easier. So cover up anything you don't want that wire to touch. You run your jumper and then you cover it in UV resin so it doesn't make contact with anything else. So I had to do these. And then all of these traces right here. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, I think 16 if I counted that correctly. I ended up having to drill this card out more, and that's not including all of the traces that come off of that are next to the screw hole up over here in this area. So these are the traces. I've seen some people incorrectly refer to these as PCIe traces. Actually, a lot of articles, this is one thing that they get wrong. Some videos, these are not usually PCIe traces. The PCIe traces are over here. Most of them run straight up to the core. So these are the traces that are running through here. Like you have GPIO 22 ADC Mux Cell, PS PEX VDD enable. I don't know what this one is, but that one's important. That's the enable for PEX, so you need that, or the PEX rail is not going to turn on. That's another. This is MSVDD PWM VID, so PWM signal. You're gonna have a power stage that has no PWM output, and that's not good because if you power the MOSFETs without powering the PWM, without powering the gate, as far as I understand, that could potentially result in a MOSFET that opens its own gate and just 12 volts straight to the core. So that could be incorrect. I'm not like an electrical engineer or anything. I'm better at repair than I am at electronics. I'm getting there, but that's always a possibility. MSVDD PSI, that's I can't remember exactly. I'd have to look that one up. Depends on the controller. An LED blue driver, white driver, feedback enable, that one's going to be important. MSVDD enable, so again, another enable signal. You're not going to have MSVDD without that. NVVDD, PWM VID, LED power break, FVVDD select, 1V8P good. That's going to be needed to power the rail that's after 1.8 volts. Otherwise, you're going to be missing the enable signal for that. 1V8 enable, you're not going to be able to even power 1.8 volts if that's broken. And along with a lot of others. This is just the ones in this area. This is only, I think, layer 3. Yeah, this is layer 3. This is not including like layer 11, which is the other one that had a lot of traces on the backside, and this is not including any up here on the screw hole. So that alone, that's already a lot of work. You've got to run every single one of those jumpers. You can see how small they are. If you've ever seen 34 gauge wire, it's tiny. That'll fit this, but it's tiny. You have to run every single one of those across this crack if that's how you're going to do it. And then not only that, but you have to hope that it's not going to get bent in that area again, and that your traces that you just made are not going to crack or come undone, because if they do, you've got to scrape all the UV resin away. You're probably going to have to redo a bunch of these traces because getting to that one is probably going to cause some damage to the others, so that's not going to be any fun. Now the other option is running some jumpers. Let me actually open a photo really quick for you, and I'll show. This is one I didn't show earlier. This was a 3080 Ti that I bought a while back. This had a really bad, this was the one with the really bad crack. And I wanted to try a different method. Instead of instead of repairing the traces right there, because I wasn't sure about the integrity of this and whether it would get damaged in the future again, I instead drilled that all out. I used JB Weld, which is non-conductive as far as I understand, as far as I could find on Google, to fill everything in. Now, the bonus to that is that that keeps the structural integrity of the PCB right here. So I don't really have to worry about it cracking again in that area. And then I ran jumpers instead. Now, the jumpers are kind of ugly, sure. They're mostly not noticeable with the cooler on. The only part that's noticeable is really this right here, but it's not horrible. You stick it in a PC, you're not even going to know because you're not looking at the PCIe slot, you're looking at the cooler. So this, even this, if you're not running those traces and repairing those traces, even if you're just running across the board, this still takes a lot of time. You have to compare the board view. I had to do this manually because there were no other resources. So I had to figure out what every single trace was. I had to look at the trace view and say, okay, this goes to here. I had to figure out which layer the via went to the next layer, to the next layer, and then figure out the whole trace. Then compare that to the board view and say, okay, I can run from this resistor to here, or what's the shortest path I can run a jumper from. Some of them I was able to find some vias to attach to, or some shorter spots to run jumpers, so I didn't have to run them all the way across the board. But you have to make sure that you have something on this side of the crack going to something on this side of the crack. Here is what the backside looks like. Again, even more jumpers to run. I think I probably had to run, oh geez, I should have counted them, maybe 30 or so for this repair. So there's one that goes all the way across the board, all of these that come down to vias and stuff like that. And then not only that, but then you have to check all of the connections to make sure what you've done is actually completing the connection properly, how it should. So that's more time that you have to spend probing all of these, making sure that all the connections go to exactly where they are, especially when they're on the front and back of the PCB. You got to check the connection that way. That can get kind of annoying. So more of a time sink. Here is another photo. Same card, and another photo of the backside. So repairing these is something that's not easy at all. A lot of times it's not even really feasible. It's not even worth it. This card in particular still has issues. I've still yet to fix it. And that's going to lead into the next thing that I want to talk about, which is if the card doesn't crack, you're going to have cracked solder or ripped pads under the memory and potentially under the core. Now, I've seen this across many cards. I've seen this on MSI, I've seen this on NVIDIA FE, I've seen this on the Dell or HP OEM cards, I've seen this on Gigabyte. It happens on everything. And it happens from that PCIe slot getting twisted. So the card gets twisted from the PCIe slot. There are solder balls under this. If you guys are not familiar, the memory and core are attached with what's called BGA, which means ball grid array. And it's just a bunch of balls on the underside. They're all the same size. They're made up of solder, and there are a bunch of pads on the PCB, and those attach to all those. But the problem is if you get any flex, those balls will either take the pad off of the board, which can be repaired, but it's more work again, and it's not super easy. Again, you need specialized tools for that. If you have the tools to do that crack repair, you've got the tools to do this, but it's just more stuff that you need. Additionally, you need hot air for doing this, so you could get away with no hot air with doing just the trace repair if you really didn't want to, or if you really didn't have hot air, but you're not going to get away with no hot air for doing the memory modules or the cores. You just can't. You can't. So this is an example of kind of what that looks like. You can see sometimes it rips pads off of the memory itself. Sometimes it rips pads off of the core itself. Sometimes it rips pads off of the PCB, and other times you'll get like a good mix, or you'll have cracked solder. So neither pad gets ripped off, but the solder connection gets broken, which means sometimes you'll have a good connection and other times you won't. So sometimes your card will work, other times it won't work. If you take the cooler off, it might not work. If you have the cooler on really tight, it might work. So this is kind of an example. You can see any of these that are this like tan brownish color, those are ripped pads on the memory. So all of these, unless you get really lucky and you happen to rip like just one or two ground pads or some NC no connection pads, then you can reuse the memory module. But a lot of times these need new memory modules. So you can see this one's okay. This one has a good amount of ripped pads. That one's probably done for. And this one has way too many to even be considered useful. Now, sometimes what this can be is you can also see like the orange or tan color on here, but it's actually the pad from the PCB that you're seeing. So it's hard to say which is which on here. These look more like the memory pads are ripped off, but it's probably better to have the memory pads ripped off like this, because then you can just replace the memory bank, which is much easier than actually having to repair the pads on the PCB. Then you've got to restore the pad. You need to use UV resin on those to hold it down so it doesn't move when you're soldering. And then you have to reinstall the memory module. So that is a fix for these. You remove this memory module. You can see if there's any cracked solder just by the way that the solder looks. And then if there are any ripped pads, you fix those. If the memory module pads are ripped, you replace the memory module, reinstall it, and the card will usually work. I've seen that happen again on basically any card out there. It is kind of just a downside of putting these memory modules by the slot right here. I don't think it happens too much on the core. If it's happening on the core, you're most likely going to see a crack because it's going to take a lot of force to get those balls broken or pads ripped on the core. So you're most likely going to have a crack anyways. I guess that depends on the card though and how strong the card is. Like maybe the Asus you could get the core without cracking the PCIe tab, but I would think the PCIe tab would probably still be cracked at that rate. But either way, that's still an issue. I would like to see them potentially mounting these further away, because that BGA is just, I don't know, it's probably one of the most common repairs that I get nowadays on 30 series and 40 series cards is these memory modules. This card only has one, but some have 3 down here. I had one that I just had to replace 3 memory modules on because they all had ripped pads on the bottom. That's a couple hours of work depending on how smoothly everything goes, plus new memory modules, which usually run maybe $8 to $10 a piece. The 2 gig memory modules, which more cards are using now, are even more expensive. So those can be $15, $20 a piece, if not more sometimes. So it's expensive both in labor and in parts, and it's not really fun to deal with. That's kind of a side issue, but it kind of also relates to the same thing. So the problem as well with that is if you have a card that's got a crack, there's basically a guarantee that you're going to have to reball and or replace one or more of these memory modules. This one definitely in this cracked card, the one that I have that's really bad, I am definitely going to have to replace this memory module right here and this one right here, and well, or reball them potentially, and probably the core as well. So that card is actually just being used as another donor card. I got an Asus PCB that was given to me by a friend of mine, thank you, and I'm going to have to swap all the memory from this card to that card because that crack is just too bad. It would take me too long to reball all of that and possibly repair some pads and swap over and fix all of the traces. It doesn't make any sense to do that. So it's really not economically viable in most cases, and it just takes too long to repair. So all in all, I would like to see Gigabyte fixing their issue on their end as best as they can in the next redesign or whatever next PCB they have. I would like to see this moved away from the locking tab. I would like to see the shorter locking tab like the Asus card. I would like to see, again, I don't know about the composition of their PCB, but I would like to see a stronger PCB if possible, because again, Asus has the shorter locking tab and they have the screw hole, but they don't necessarily have the same issue. Now, do I think they'll fix the issue? Probably not. I hope they will. Maybe they'll revise it in future revisions, or well, probably not future revisions of this PCB, but in a different PCB, a newer PCB that they make for like the 5000 series or whatever. And I think I've seen a couple of the 4000 series cracking, but only time will tell with those. We'll have to see. It's been about 3 years since the release of the 3000 series, and we've seen quite a bit, but the 4000 series haven't been out for very long. So we'll have to see with those. Hopefully they improve it, change some things. Again, I would like to see some sort of extra support on this side, either by manufacturers including a support bracket or extending the support in some way to mount it to like where your hard drives sit, the hard drive bay, or cases that come with some sort of built-in support for your graphics card, or case manufacturers working with graphics card suppliers or manufacturers to design some sort of extra thing you can attach to your card, or just designing specific cards to come with an extra bracket to be bolted into the case on that side. Anything like that would be a great improvement. not only on Gigabyte's side, but on for Asus or for MSI or for Nvidia, the FE cards, or anyone that's manufacturing these cards. I would like to see that, because again, the bigger these coolers get, the more heat these cards need to dissipate, the heavier the cards get, and the more weight that's put on the PCIe slot. And you can see, like, they're cooled up to here usually because you want to cool the power stages, but there's not much cooling over here. It's mostly from the memory and the core, and then everything over here, and then most of the cooler hangs off this direction. A lot of Gigabyte cards hang off far past their custom power cables because the power cables go to the right more. So yeah, I would like to see that improved. We'll see what happens. I don't really expect them to change their policy on RMAs either, unless some huge thing goes off. But as someone said, I don't think Gigabyte really has like a cult following like some other people do. So I don't think they have a lot to uphold in the first place. If you're buying cards, especially 30 series, I would definitely steer away from Gigabyte. Grab something that's more solid, like an Asus. Even though it's a little more expensive, you're not going to have to worry about the cracking and the whole no warranty thing. I honestly, I would even grab like another card, grab like a Zotac or a PNY or some, I guess, quote unquote off brand, or like a more not less mainstream card compared to the Gigabyte. I would say grab one of those over the Gigabyte. So anyways, that is my 2 cents on everything. I hope that provides some good info. I hope that filled in some gaps and provided some technical, a more technical view, more repair centered view compared to the entertainment only view that some other people have provided. I feel like they were missing quite a lot of info, so my goal was to fill in those gaps, and I hope that did that. If you guys have any questions, if you think I missed anything in this video, please toss it down in the comments. I'll reply to any of them. And that is going to be it. Thanks for watching, and I'll see you all later.